So this is part two of 8.1, and I want to continue where I left off. The place that I was kind of looking at was that in 8.1, in chapter 8, it's called confidence intervals. And 8.1 talks about what is determined as the mean, not the proportion. That's coming up down the road, but the mean when sigma is given. That's the key. When the population standard deviation is given, then there's a particular formula that you would use, and that was in the early, the first part of 8.1's video. Right now, we're going to end up using it, looking at some applications of it, and wrapping this 8.1 up. So let's get started. Let's share my screen. So I'm looking at the questions that are being posed, A, B, C, D, and finally the E at the bottom. I'm looking at things that I'm going to need, definitely going to need the sample size, and that's going to be, it looks like 25. Now, because it's 25, the sample size is too small, I have to look to see if I can even do this. I'm looking for the key phrase that the distribution is normal, and it does say that. Otherwise, I couldn't do it. So since it says normal, it doesn't matter about the sample size. Next, I'm going to need X bar. X bar, usually it has the word sample, and of course it's the 25 people, in this case working women in California. Those 25, they give a sample average. So it's the 25, that's why it's X bar, $45,000. And we assume, see how the end of the sentence stopped. The rest of it, it even says population standard deviation. So there's your sigma. Sigma is given to be $6,000. It says nothing about the standard deviation of the 25 women. It's nothing. This one is about the 25 women. This is not. This is about all the women that are out there that are working in California. So number one, out of these symbols, what would the point estimate be? You could say N, because that's a sample size, but the one they're looking for is the X bar. That's population. So point estimates are samples. Parameters are population symbols. So point estimate, X bar equals 45,000. The next thing they want, I want you to find is sigma divided by square root of n. Don't forget that's the same as, let's see, that would be sigma sub X bar actually. Remember that from chapter 7, I think it was. That's the same definition. And it turns out that it's 6,000 divided by square root of 25. That's convenient because it's 6,000 divided by 5. And we can simplify that by saying 6,000, I think it's 120. So I'm going to double check that. And see, I made a mistake. Careless mistake, it's 1,200. So 1,200. And that's money, so that's dollars. The next part asks for computing the margin of error. Now the margin of error is a formula, and I'll write the formula down again. It's everything that is, including the Z, one second, and I'll be right back. Okay, back at you. Share that screen again. So the margin of error formula is the following. You got sigma divided by square root of n. Oh, that's the margin of error. The question is what's that Z sub alpha divided by 2? And you know, last video I said, don't worry about the table. I'm actually going to have you look at your table because there's going to be something you're going to need to use from the table anyway coming up shortly. So let's have you in your textbook or in your packet, find this in what we call table D. And this is in Daniel LaRose statistics text. Or you can find it in the packet that you actually bought. So we need to know, and eventually it's the 99% confidence. So you'd say for the 99% confidence interval. So in your table, it's actually in the back cover of your textbook as well. Excuse me, it is not. It is in your table featured in your textbook. And I'm flipping there. Give me a second. Wrong page. Here we go. So here's table D. Table D. 95%. We want a 99% confidence interval. Let's double check to make sure which one it is. Yeah, 99%. So 99%. The Z score, we call it Z score, that I'm looking for is all the way down at the bottom, and all the way down at the bottom looks like it's right here. Let me zoom in so you can see that. Last column, way down at the bottom. You can even see the letter Z that's right over here. So 2.576. 2.576. So I'm going to write this down here. Z sub alpha divided by 2 is equal to 2.576. So on this margin of error, I'm going to have this number, 2.576 times sigma divided by square root of n. But you know what? We already know that. It's right here. So I'm going to put it right here. And taking my calculator, multiplying the 1200 by the 2.576. So I'm taking the 1200, multiply, okay, some of you are not seeing that. So I'll clear that, 1200 times 2.576. And I am seeing, again, it's money, but I'll just write it as the number 3091, so $3,091.20. That's how much error that I have from the average that was given to me from $45,000. Not given, but the sample size of 25 women having an average of 45,000. The total population of women were wondering what their average was. Well, we can say, give or take 45,000, give or take about $3,100. So we could be as low as subtract 3,100 and as high as add 3,100, and you'll see that coming up here in a moment. Because when it says construct, and when you take a look at the textbook, you want to construct this so you get an idea, and then we'll use the calculator in terms of how to grind out the answers using the technology. There's a nice little feature. To construct it, I'm reminding you that it's x bar subtract z sub alpha divided by 2, sigma divided by square root of n, less than, okay, the true population mean, and then we're adding it to the back side. Oh, but that's the same thing as x bar subtract margin of error, less than mu, less than x bar sample mean, plus the margin of error. And we found the margin of error and the x bar already from on top, 45,000. subtract. Okay, so the margin of error back up here. Here's your margin of error. So $3,091.20. And then we'll add 45 to 45,000. We'll add the $3,091.20 again. And the result that I'm going to get here will be the same result as using my technology. So on the multiple choice portion of the test, this is all fine and dandy using this so you can see it. But to actually get the answer, what's the 99% confidence interval for the mean? Here comes the instructions for your calculator. And I can't remember if we've done this already. And I will show you the instructions. Okay, it's right here on the previous page. It's found on page 441. So good. I'm going to go back over to 441 for you in your textbook. Page 441. And you can follow along in your textbook. Page 441, Z confidence intervals. So this is the one that we've got sample statistics. Right here, summary statistics. So I'm going back up to here and we're doing a stat button and then highlight the tests. So clear that out. So stat button, which is right here. And then the next thing is going to highlight the tests and then press 7. See, Z interval right here. You could highlight, go down, toggle down, and enter. That'll work. Nope, not 8, but 7. And now you're just going to input the data under statistics. So you want statistics, which I have. And now our sigma is 6,000. Literally 6,000. And our X bar is 45,000. And our N is 25. Confidence interval is 99% or 0.99. And now we just go and calculate. Now the result that I see right here, $41,909. $41,909 would be this amount. I think I got a mistake right here. I forgot my 1, didn't I? Yeah, you guys are probably seeing that. That happens often. So if I subtract 45,000 and $3,091.20, I'm going to get, it looks like to the nearest penny or nearest dollar, 41,000. Let's see if that's true. Oh, and this one over here should be 40. Well, you can look at it's going to be 48,000. 091. They're taking off the pennies. I'm thinking that it's the way the calculator is set up in terms of the decimal approximation. So right now, this is good enough from the calculator's point of view. 091. And you know what? On the test, the multiple choice test, if you see the 20 cents, well, then you're going to pick whatever's the closest to this. And, you know, even if it doesn't have 20 cents, you're just going to pick the closest. And that's the confidence interval. The only exception to that is your little sentence. And I'm going to squeeze that in over here. It's the interpret. Here's the interpret. The interpret's in the sentence form, and it's a little wordy. But the first part, you can always say I'm, or you can personalize it. We are, or I am 99% confident that mu, and mu is the population average, is between, and what's mu? In wordy wise, you would end up saying the population average, the average income of all, that's where mu is, working women in California, that would be the wordy statement instead of mu, is between, and here comes the money, $41,909, and if I drop the pennies off here, $48,091. Okay, now let's take a look at another one. And this hopefully will give you an idea. And then we got one more concept to do. Okay, another example here, and again, it's a Z confidence interval. The reason for that is sigma had better be given for a Z. And of course, we have an N somewhere. And we have to know if we can do it or not. And the other thing is X bar. We have to be given X bar, which I'm sure we are. Okay, N is 40. So it doesn't matter if it's normal or not, because the sample size is big enough. So the question is, could we move forward? Yes, move forward. Because sample size is big enough. It's case, if you're thinking about case, it's case 2. That was in our textbook, case 2. All right, the 40 cups of soda, their average amount of soda in each cup is 7 ounces. So X bar is 7 ounces. And now you assume that the population standard deviation, which is sigma, is 1 ounce. And since we can move forward, then we're going to construct the 99% confidence interval. And at the same time, or afterwards, we're going to do the 90% confidence interval. So let's letter A, let's do the 99% CI. Now, I know that, well, if we're looking for the answer from our calculator, all you need to do is use TI, say 8483. That's, again, it's on page 441 in your text. We would just go through and find it. It'll give us the result. So I'll do this again. We're going to go into stat. This is on page 441. And then scoot over to tests. Scoot down to 7. That's sigma's given. It's already set up for stats this time. Okay, now I can't use 45,000 from the last one. I'm going to use the 7 ounces, which is back up to here. Okay, there's my X bar. So 7. Oh, I've got a wrong interval. I must have pressed 8. Let's go back again. One more time. Sorry. So stat, tests. Yeah, I think I hit 8. 7. And the reason why it caught me is I think originally I'm supposed to have sigma, not little s. So now I can fix this. So sigma is sigma. My sigma is 1 right there. My X bar is 7. Yep, got that. N is 40, or 40 here. And we're still at the 99% confidence interval. Hit enter. And okay, there I've got some interesting number. I'll write that down. you get 6.5927, and then you got a comma, and then you got 7.4073 parentheses. This is what the calculator, this is the calculator's answer. Our answer, maybe, version might be 6.59. Remember, we used 2 decimal places at least prior to the spring break. Ounces, less than mu, less than, and it's always mu in the middle, 7.41. And so you'd have a statement that's something like, I'm 99% confident that the average amount of soda for all, because that's what mu is, cups from an old soda machine is between the 6.59 ounces and 7.41 ounces. See, the 40 cups, their average was 7 ounces. You can't necessarily say that all of them are going to be 7 on average for all of them, but you can, with 99% pretty sure that they're going to be somewhere between about 6.5 ounces and 7.5 ounces, somewhere in between. Gosh, if it was a cup that held exactly 7 ounces, you can get some cups that would be overflowing from here. So it's probably a cup that is bigger, that could hold more than 7 ounces, of course. And letter B, it's the same thing, which is 90% confidence interval. And if you ended up using your calculator one more time instead of the formula, because again, calculator is going to get you the answer directly for a multiple choice test. The formula is nice from a previous problem that we did with the income. It's nice because you can see all the values you found that the calculator actually uses. So, but going back to the calculator, I'll go stat, tests, number 7, not 8, 7. Nope, I just did it again, didn't I? Let's try that again. Down here to 7. There, that one there. Okay, everything's the same except this one here is 90%, so 0.90. And now I'm going to hit calculate, and there's my result. So 6.74 rounded, 7.26 rounded. Maybe the answer is in an interval with mu. So 6.74 OZs, 7.26 ounces. And then you'd say the same thing right here, except it would be between, instead of these values. So look at, I'm less confident, but the range of where the ounces are narrower. I've narrowed down the possibility of what the average is. See 7 1/4 and 6 3/4 ounces. That's a wider range. Okay, and then flip this page right here. This particular problem now is asking for what they call minimum sample size. The sample size, sometimes we call it the minimum, that we can find. What's the sample size that we need to sample so that we would be within a certain margin of error? So this formula here requires you know what the margin of error is that they're given, and I'll show you that. You're always going to be given sigma, and this piece here comes from your table D. So let's write this over again. N equals so I need to know what my sigma is. Let's see. Suppose we want to estimate to within. Within, that's the key phrase, is margin of error. It's kind of the phrasing or wordy thing that you want to have your error within $1,000. So actually ME here then is $1,000. Okay, so they want to estimate to within $1,000 the average population salary of all college graduates who were business majors. So we're going to assume sigma to be 5,000. And they want to know how many business majors would we need to sample so that the average salary of all would be within $1,000. And there's your value. You're going to have to look in your table for Z sub alpha divided by 2. It's not 95%, but it comes from the table. So here's the table again. Look at this. Back to the table. Get my finger on it. Here it is. So 95% confidence interval. I'm actually on this column right here. And so for Z's, I go all the way down to the bottom, all the way down to the bottom, all the way down the bottom, all the way down the bottom. And that's the one I want. I'll zoom in so you can see it. That's the one I want right there, 1.960. Remember that, 1.960. And now I can use my formula. So this is 1.960 times sigma, which is 5,000, all over margin of error, which is 1,000. Okay, so this one here, I actually have to use my calculator the old-fashioned way by replacing or shoving in all of this in my calculator carefully. So here we go. I'm going to put parentheses first, and then I'm going to go back into that alpha y equals to find my fraction. And now I'm going to go 1.960, and I'll put times. That's this right here so you can see what I'm doing. And so I'm putting times 5,000, go down here to 1,000, scoot over, looks like I'll put another parentheses, and then hit the square button and keep my fingers crossed. So what this is saying is I need to sample 96 people. We always round up, so 97 people. So 97 people, always round up. We need a sample people to ensure that we're within $1,000 of where the real average salary for all graduates that are business majors are. Okay, let's take a look and see if there's anything else. Okay, I'm looking at this. Now, I think we're gonna have to do is this next problem, I see raw data here. The raw data is going to require that you be taught or shown how to use your probability dot plot. And I think I'll put that into your third part of 8.1, 8.1 third part, and go from there. So I'm going to end this session now. So I'm going to end this session now and see you on part 3 of 8.1.